Elixir School. Pattern matching. Pattern matching is a powerful part of Elixir. It allows us to match simple values, data structures, and even functions. In this lesson, we will begin to see how pattern matching is used. Match operator. Are you ready for a curveball? In Elixir, the equal operator is actually a match operator, comparable to the equal sign in algebra. Writing it turns the whole expression into an equation and makes Elixir match the values on the left hand with the values on the right hand. If the match succeeds, it returns the value of the equation. Otherwise, it throws an error. Let's take a look. X equals 1. No match of right-hand side, value 1. Try that with collections. Pin operator. The match operator performs an assignment when the left side of the match includes a variable. In some cases, this variable rebinding behavior is undesirable. For these situations, we have the pin operator, caret. When we pin a variable, we match it on the existing value rather than rebinding to a new one. Let's take a look at how this works. Elixir 1.2 introduced support for pins in map keys and function clauses. An example of pinning in a function clause. Note in the morning example that the reassignment of greeting to morning only happens inside the function. Outside of the function, greeting is still hello. Control structures. In this lesson, we'll take a look at the control structures available to us in Elixir. If and unless. Chances are you've encountered if to before, and if you've used Ruby, you're familiar with unless too. In Elixir, they work much the same way, but they are defined as macros, not language constructs. You can find their implementation in the kernel module. It should be noted that in Elixir, the only falsy values are nil and the Boolean false. Using unless is like if, only it works on the negative. If it's necessary to match against multiple patterns, we can use case too. The underscore is the catch-all. The underscore variable is an important inclusion in the case to statements. Without it, failure to match an error to match will raise an error. Case clause error. No case clause matching even. Consider underscore as the else that will match everything else. Since case relies on pattern matching, all the same rules and restrictions apply. If you intend to match against existing variables, you must use the pin operator. Another neat feature of case is its support for guard clauses. Check out the official docs for expressions allowed in guard clauses. Cond. When we need to match conditions rather than values, we can turn to cond 1. This is akin to else if or else if from other languages. Con do, expression. Like case 2, cond 1 will raise an error if there's no match. To handle this, we can define a condition set to true. It's the catch-all. With. The special form with is useful when you might use a nested case statement or situations that cannot cleanly be piped together. The with expression is composed of the keywords, the generators, and finally an expression. We'll discuss generators more in list comprehensions lesson, but for now, we only need to know they use pattern matching to compare the right side of the arrow to the left. We'll start with a simple example of with and then look at something more. With OK first. So we set up some stuff and then do. In the event that an expression fails to match, the non-matching value will be returned. Now let's look at a larger example without with and see how we can refactor it. So we have a case where we do a repo insert, and if it works out okay, we go through this. Otherwise, we throw this error or return this error. Another case inside. When we introduce with, we end up with code that's easier to understand and has fewer lines. With first condition, second portion, important stuff if both of these are given. Otherwise, returns this error. That is pretty handy. As of Elixir 1.3, with statements support else. It helps to handle errors by providing case-like pattern matching in it. The first value passed is the first non-matched expression. Functions. In Elixir and many functional languages, functions are our first-class citizens. We will learn about the types of function in Elixir, what makes them different, and how to use them. Anonymous functions. Just as the name implies, an anonymous function has no name. As we saw in the enum lesson, these are frequently passed to other functions. To define an anonymous function in Elixir, we need the fn and end keywords. Within these, we can define any number of parameters and function bodies separated by an arrow. Let's look at a basic example. And then you call it with the dot. The ampersand shorthand. Using anonymous functions is such a common practice in Elixir, there is a shorthand for doing so. As you probably already guessed, in the shorthand version, our parameters are available to us as &1, &2, &3, and so on. Pattern matching. Pattern matching isn't limited to just variables in Elixir. It can be applied to function signatures, as we will see in this section. Elixir uses pattern matching to check through all possible match options and select the first matching option to run. Named functions. We can define functions with names so we can easily refer to them later. Named functions are defined within a module using the def keyword. We'll learn more about modules in the next lesson. For now, we'll focus on the named functions alone. Functions defined within a module are available to other modules for use. This is a particularly useful building block in Elixir. If our function body only spans one line, we can shorten it further with do. Armed with our knowledge of pattern matching, let's explore recursion using named functions. Function naming and arity. We mentioned earlier that functions are named by the combination of given name and arity, the number of arguments. This means you can do things like this. We've listed the function names in comments above. The first implementation takes no arguments, so it's known as hello 0. The second one takes an argument, so it is known as hello 1, and so on. Unlike function overloads in some languages, these are thought of as different functions from each other. Pattern matching, described just a moment ago, applies only when multiple definitions are provided for function definitions with the same number of arguments. Functions and pattern matching. Behind the scenes, functions are pattern matching the arguments that they're called with. Say we needed a function to accept a map, but we're only interested in using a particular key. We can pattern match the argument on the presence of that key, like this. Now let's say we have a map describing a person named Fred. These are the results when we call greet or hello with the Fred map. It will ignore these other bits, and it matches these in. It's like these are on the right, and then this is on the left. These are the results we'll get. What happens when we call the function with a map that doesn't contain the name key? Function clause error. No function clause matching in greeter1 hello. The reason for this behavior is that Elixir pattern matches the arguments that a function is called with against the arity the function is defined with. Let's think about how the data looks when it arrives to greeter1 hello. pass is evaluated. It's an argument. Yeah. It finds that there is a key that corresponds to name in the incoming map. We have a match, and a result of the successful match, the value name key on the right is bound to the variable on the left. Now what if we wanted to assign Fred's name to person name, but we also want to retain awareness of the entire person map? Let's say we want to inspect Fred after we greet him. At this point, because we only pattern match the name key of our map, thus only binding the value of that key to our variable, the function doesn't have the knowledge of the rest of Fred. In order to retain it, we need to assign the entire map to its own variable for us to be able to use it. Let's start a new function. Nice. Let's put an equal. Remember that Elixir will pattern match the argument as it comes in. Therefore, in this case, each side will pattern match against the incoming argument and bind to whatever it matches with. Let's take the right side first. It's like a triple, it's like a triangle. Things are dropping in. It's like, oh, match with this side, match with this side. So now we'll call the greeter to hello, and we can see all of Fred's information. But a call without the name key will still fail. So we've seen that Elixir pattern matches at multiple depths because each argument matches against the incoming data independently, leaving us with the variables to call them by inside our function. If we switch the order, we will get the same result. We swap the variable, we get the same result. Remember that even though it looks like this, the pattern matching is pattern matching against these two. That's not the case. They're actually each pattern matching against the passed in argument. Triangle, right? Triangle, key, triangle, key. Maybe you could add another equal. Summary. Functions pattern match the data passed into each of its arguments independently. We can use this to bind values to separate variables within the function. Private variables. When we don't want other modules accessing a specific function, we can make the function private. Private functions can only be called from within their own module. We define them in Elixir with defp. Guards. We briefly covered guards in control structures in the control structures lesson. Now we'll see how to apply them to named functions. Once Elixir has matched a function, any existing guards will be tested. In the following example, we have two functions with the same signature. We rely on guards to determine which to use based on the argument's type. When is list, do this. When is binary, do this. Default arguments. If we want a default value for an argument, we use the \\, the argument, and then double \/ value syntax. Default English. When we combine our guard example with the default arguments, we run into an issue. Let's see what that might look like. Definitions with multiple clauses and default values require a header. Instead of such and such. though, has multiple clauses and defines defaults in one or more clauses. Elixir doesn't like default arguments in multiple matching functions. It can be confusing. To handle this, we add a function head with our default arguments. Function head. The pipe operator. Pipe greater than passes the result of an expression as the first parameter of another expression. Introduction. Programming can get messy. So messy, in fact, that function calls can get so embedded that they become difficult to follow. Take the following nested functions into consideration: foo, bar, baz, new function, other function. Here we are passing all these in. Otherwise, you can another way to write this is this. So it's passing the return value of this as the first argument to the next. The pipe takes the result on the left and passes it to the right-hand side. Best practices. If the arity of the function is more than 1, make sure to use parentheses. This doesn't matter much to Elixir, but it matters to other programmers who may misinterpret your code. It does matter with the pipe operator though. For example, if we take our third example and remove the parentheses from the ends with, we are met with the following warning. It's ambiguous. Parentheses are required when piping into a function call. Alright, I think that's all for now. Later.